Welcome back to ETHShanghai.
Thank you for having me.
Yeah, you were here last year, and this year was really different. We expanded this into a very fruitful 2-day event, combining both, one online venue to two offline venue, one in Singapore, one in Shanghai. Yesterday was definitely a feast and really really amazing. And today the format has changed. Everything will probably very much online, but we have at the same time thousands of watchers currently watching the live stream. So thank you so much for taking your time, going back to East Shanghai, and be willing to give your talk. And
Absolutely.
yeah, so we my name is Afra. In case you don't know, I'm one of the core contributors to Mask Network, which is proudly hosted this year's East Shanghai again. Um, it's been a lot since last year in May, and I'm really, really excited to hear your new talk about the importance of decentralization in the blockchain storage space. So why don't you start your talk and then just shed more lights to us about the decentralized storage solution?
Absolutely, I will do. Okay, I'm showing my screen. Can you see that?
Yes, I can see it. Thank you so much, Sam.
Awesome.
I'll hand the mic to you.
Okay, thank you. All right. So thank you everyone for joining. I appreciate having the chance to talk to you tonight. So I want to talk to you about what Arweave is, which is on-chain data storage at any scale. And this is essentially inspired by the first use of Bitcoin, which was not, interestingly, a financial transaction, but it was the embedding of a newspaper headline into the Bitcoin blockchain in the first block, where Satoshi was able to signal that the block started being mined on the 3rd of January, 2009. We thought that this was a really exciting, would you say, kernel of an idea. And this core premise that you can embed pieces of information in a ledger that is stored in many different places around the world with no single centralized point of failure. And we were initially excited to build Arweave, which is essentially the massively scaling up of this idea, so that we could build an immutable ledger of history. Particularly, we wanted to not just embed newspaper headlines, but full newspaper articles, so that there was a sort of common neutral ledger of history that no single person or group would have the authority or ability to change, a sort of shared collective memory for humanity, basically. Yes, and so we saw that with Bitcoin, that was the core of this idea, but it didn't scale, right? Even today, when you're trying to embed ordinals or something in Bitcoin, the prices are staggeringly expensive. And so with Arweave, we thought, okay, let's take that, but let's solve two fundamental problems. Let's make it so that you can store arbitrary amounts of data inside, and let's make sure that you can do so with a sustainable model for payment for that data storage, right? Because as soon as the ledger gets too large, you have to have a way to pay for it. And for the first system, we built what we call succinct proofs of random access, which I'm actually not going to get into today, but you can look online. If you just Google Arweave mining mechanism, you'll find all about it. And the second thing is also the Arweave endowment structure. Basically, what we do here is we say, okay, you pay for 200 years worth of storage when you put data into Arweave. As the cost of storage declines, that 200 years expands out. Strangely enough, if the cost of storage declines at a rate higher than 0.5% in a given year, you actually end up with more storage purchasing power at the end of the year than you did at the beginning. So it's sort of an endowment-like structure where you're gaining interest in the form of storage purchasing power from the deflationary effect of storage price declines. So we built this system. We started 6 years ago. And as of today, we're running at a rate of 91 million pieces of data added to the network every month. Actually, this month's not quite over yet. So I'm a little bit hopeful that we might pass 100 million this month, but probably slightly less, maybe next month. Yeah, so this archive has grown extremely large, and it's been a really rewarding experience to see the community around it grow. And they've taken it from this idea of just building a neutral ledger of history, on-chain history that is replicated all around the world, to something far greater. They've used it for all sorts of different things. there's now an enormous ecosystem on Arweave building literally hundreds of different applications that use on-chain data in composable ways. One interesting way that recently, started happening was Lens started to use Arweave. So Lens is an open social network, essentially. And they realized that they could use Arweave to scale the way that they were storing their data, such that they could store, in this case, in practice, I took the screenshot earlier today, 300,000 transactions on Arweave, and it cost them $102, which is 0.0003 cents per transaction. And that's a little bit expensive. The minimum transaction cost on Arweave is 11 thousandths of a cent. So really, we've taken this idea of on-chain data storage and scaled it in an enormous way, I think. The bundles that you use to submit data to Arweave are essentially arbitrary in scale. But that's, if you search Arweave bundling, you can find out more about that. That's not the topic of this talk, although I think it is kind of interesting how we're able to make that work. In the Solana ecosystem, we're storing something like 90% of all of the top 100 NFT media collections, for example. But we think this is just the tip of the iceberg. We think that one of the most exciting things about Web3 data or on-chain data has yet to really manifest itself. And that is the composability of this data, right? So when you store data in Arweave, it is accessible in web browsers as well. You can think of it kind of like an on-chain web. We call it the perma-web for short. And that means you should be able to remix the data in Web3 like you remix smart contracts in DeFi, right? So DeFi smart contracts, we all know that you can sort of take the DAI contract and you can compose it with the Uniswap contract, and then you can build your application on top of that, and you're using sort of all three in like they like to call it money Legos fashion, right? You're building with Lego, except the bricks are programmable money. Well, in theory, with Web3 data, you should be able to remix the data in the same form and build upon it, right? But curiously enough, this hasn't actually happened so far. And so we've spent a lot of time in the Arweave ecosystem thinking about why this is the case. Or it's only happened in, I would say, sort of niche categories like NFTs, which I think is just like I said, tip of the iceberg of what is possible. We think that there are two main reasons that this hasn't happened so far. So the previous systems lacked structure of data, and the second is incentive compatibility. Structure of data, right? So you've got a big, open, decentralized data storage network of some form. But if you only have content identifiers, and the first sort of distributed, at least, it's actually a distributed hash table. It's not a storage system. is IPFS, the interplanetary file system, they call it. So it's a way of saying, I've got this hash. If it is somewhere in the network, please guide me to where that data is. And you do so by these things called content identifiers. They're essentially hashes. But there's a problem with this, which is they cannot be easily queried or composed upon. So when you're looking at the IPFS network, you can't just say, hey, give me all of Bob's tweets from the last day that have more than 10 likes. That's just not the kind of question you can ask it. All you can ask it is, hey, can you find me a way of routing to this particular hash? With Arweave, we solved this with what we call the metadata tagging system. So when we were building Arweave, as I said, we were trying to create a sort of archive structure. And that meant that everything that goes into the network is not just referred to by its content identifier, it is referred to by what you can think of as a provenance identifier, a data entry ID. And so this means that you don't just have the data, although you can actually, if you want to, refer to it by its content ID or by would you say just the hash of the data? Although we wouldn't suggest that you do for the reasons I'm about to explain. You have that data, but you also have arbitrary metadata attached to it. So in this case, you can see that this is uploaded by an application called Kive. It's a stream of blocks from another blockchain. Chain ID is Corellia, and it's from a pool called Zero. And all of these are pieces of metadata that can be indexed upon. And then, of course, you also have pieces of metadata that are added by the blockchain itself. So you can see that this is currently pending. Its age was an hour ago. There's data in Arweave that's now 5 years old, and you can prove those properties of, or the properties of that metadata, that it hasn't been altered, it hasn't been tampered with, just like a normal blockchain, except applied to data. So these tags here, they are arbitrary in structure. You can decide what they should be, but they can be queried upon. So here, for example, is a GraphQL query that you can run against any indexer that is looking at the Arweave network. They all use this unified GraphQL format so that you can swap out the infrastructure. So sort of Arweave, this big open data lake in the middle, then there are these indexing services on the edge that all use the same language, and you as a user can come along and you can use one or the other. You can swap them out, giving you proper decentralization. So here is an example query that says, hey, give me everything that's uploaded with a content type of text HTML. So it's a web page, looking for all of the web pages on the network. Then it also has a user agent, Arweave Auto DPL. That was a bot that was running for a while, trying to scrape up parts of the centralized web that are very valuable and put them inside Arweave. As a interesting data set there. For example, there's, I think, 700,000 or so first, what do you call them, primary source web pages regarding protests all over the world, but perhaps we'll talk about that another time. But you can find those if you're curious what they're about. Yes, so you can query the network now, and then you can see all of the data that everyone else has added to it. And it's open and composable in a way that content identifiers can never be, because they're just telling you about the data. The metadata is just as important. And so on top of this querying system, you can build full decentralized web applications. So here's a system called Now. You can get to this using any Arweave gateway. As I described, those indexes can be swapped out. So if you have the rconnect web extension installed, for example, you can just say AR:// now, and it will take you to this web application on your favorite gateway, on your favorite indexer. But if you don't have it installed, you can go to now.arweave.dev or now.g8way.io or any other Arweave gateway. It's a fully decentralized web application. That application itself, the HTML, CSS, and the JavaScript, they all live on Arweave. They're stored on chain. It is querying these indexes, which can be swapped out at will, so they're properly decentralized. And then you're receiving information about data entries that are stored on the network, other people's data entries. And this information is not, interestingly, there is no, this particular app has no way to submit data. So this is only building upon data that is uploaded in other applications. It's composing on other people's data. Now, of course, you should have an application that allows you to upload, and maybe they could add that to Now. But the point here is it's showing the radical composability of the system that is enabled by the fact it's richly annotated with context, and that context is indexed, and you can query against it. Building fully decentralized on-chain web applications, kind of doing for web applications what smart contracts did for finance, right? There's this idea of properly decentralizing and making permanent and openly and permissionlessly available, but this time for social stuff and the things that you normally associate with the web rather than things you would normally associate with doing at a bank. Okay, the second problem is incentive alignment. And this we're pretty excited about because we launched something today, literally, in fact, which we think is a major, major cog in solving this problem. So in Web 2, data is a moat. That is, I want to, if I'm starting a web service, imagine that I'm starting twitter.com or Weibo. I want to create not just a web application that people want to go to, but also a set of data, normally a social graph, but it can be other things as well, that is stuck inside my system such that people have to keep coming back to my system in order to, in order to gain access to that experience. They can't export the experience anywhere else. And in Web3, until this point, we haven't presented a better alternative yet. And this we found when we were speaking to people. So obviously, Arweave's been available for 5 years on mainnet, running in a mature fashion. It doesn't, it's literally had zero downtime in 5 years. So there's a lot of people that use it and are building on it. But we were speaking to them. Why is it that you don't submit, I don't know, they love to use it to store data for long periods of time, but why isn't it that you don't submit like smaller pieces of data that might be interesting for shorter periods, so that other people can compose upon it? And the answer is, well, I like the idea of sharing data. That sounds cool, but why should I prioritize doing that today? Because ultimately that might actually lessen my bottom line, my way to make revenue, not increase it. And so this is a fundamental incentive incompatibility problem. And we think that it's getting in the way of something very fundamental. Everyone sees this, would you say, diamond in the rough, this opportunity with composable data that, information found inside Twitter could be reused inside TikTok, or perhaps more likely, data from YouTube could be reused inside TikTok. That would be a good experience from the end user's point of view. And from the content creator's point of view, as long as they're getting paid, they would be happy with this too. So like, why is it we couldn't do this? And I think the answer is incentive incompatibility. I think about 18 months ago, we started working with Creative Commons that made the Creative Commons open licenses, CC0, for example, and CC BY, ND, and so on, which are essentially ways that you can tag your content in it to make it open source. But what we found by speaking to them was remarkably, I think they said 97 to 98% of data on the existing web is license ambiguous, which is incredible. So you go somewhere on the web, there's a 96, 97, I think it was 98. Well, look it up. It's you have access to the internet. Yeah, so that number approximately is the likelihood that you are going to be unsure that you can reuse that data, which is really quite profound, right? So we have this incredible library in the web. Like there are these problems with it. It forgets stuff particularly, but it is an incredible resource. Yet actually to remix and reuse that data, most of the time, almost all the time, you're not going to be sure whether you can reuse it. And it's not that the license is restrictive, it's just that you just don't know. It's a nightmare. And so we worked with them to create the ANS 105 license standard on Arweave. So of course, Arweave, as I described, has these this tagging system, which lets you basically add arbitrary metadata. And these tags cannot be separated from the content. So if you have an Arweave TX ID, we call them, a transaction ID, then you cannot give that to me without also giving me the metadata. And that's interesting because if you just embed in the metadata, hey, the license is CC0, for example, then even if that transaction ID is embedded, I don't know, like the image is embedded in another web page or something like that, so it's kind of taken away from its original setting on the web, the license information still carries with it. It still moves around. It's atomically associated with the data. You can't unstick them. Yeah, and so we got really excited about this, and so did they. We worked together on this license standard for adding licenses to data on the permaweb. And then now you can license all of the data, which was a great first step. But we didn't think that this was quite enough. So this lets you, for example, use CC licenses. You could use other licenses, but without having good proformas, if you will, defaults, then people are unlikely to do it, right? And that's why we built the universal data license that we literally launched earlier today, which we're super, super excited about. And basically, it is a programmable license for the would you say, contract for there's a phrase, meat space. I don't know if that translates very well, so I'm sorry if not. But it's a license for humans. It's a contract for humans. It's not a smart contract, but it is programmable. So you can tag your transaction on Arweave with the universal data license, and you can then use the other tags to specify things like, you can use my data, but please make sure that you send a tip, a reward, every time you do so of 1 cent to this address, for example. Or you can reuse my data, but please make sure that you credit me. And these are just tags that you can add to the transaction. And this is set up in such a way that the license works globally. The tags are easy for developers to understand, and the tags imply text in the license. So the license is written in such a fashion that it looks up, if you will, what the tags are. And so you don't need to mess with any of the legalese, as is described, the legal text of the license in order to change its form and its properties as a developer. Super, super simple to get on board with. And licenses, I know they're kind of like boring in a way, but without them, the world doesn't work. And this is a way that you as a developer and I as a developer can customize a license and make it clear to the world how your data can be reused, and subsequently generate for yourself an additional revenue stream, right? Because you're making the data available for other people to license and pay you for in some form without touching the complex, nasty, and boring legal stuff. Yeah, so we're very, very excited about this. You can find out more about it if you just search Universal Data License Arweave, or if you could look at the rwiki, if you go to rwiki.arweave.dev, there's an article there about it, or just the Forward Research Twitter account or Arweave Eco Twitter account. It's like pretty much the latest thing on those timelines. Yes, we're very, very excited about this because it provides the framework the developers can use to easily communicate to one another. Hey, here's a piece of data. You can make use of it if you want. Here are the what do you say? Well, the licensing terms. Here's what you need to do in order to be compliant. And that provides this secondary revenue stream for the developers, but it also means from the user's point of view, now you upload, instead of to the web, you upload, instead of to a service on the web, like YouTube or what have you, you upload to the entire web in one go, and you can choose the licensing terms. And then it's the platform that decides whether they are going to accept your terms and conditions, not the other way around. So this goes even deeper with what we call profit sharing tokens. Basically, a piece of data on Arweave has these tags, and Arweave, interestingly, the smart contracting system on Arweave, it's called SmartWeave, allows you to start smart contracts just from the tags of a piece of data. Now the tags are atomically associated with that data, right? So that means that not only do you have the data and the metadata embedded in the single identifier that we call the transaction ID, but you can also now have the contract that's saying, for example, who the owner of that piece of data is inside that one identifier. The whole thing is sort of, well, it's atomic. And this has been running in production, these atomic assets, we call them, for a couple of years now. And they're pretty exciting, I think. We're pretty sure that they are the right way to do composable data, because imagine it like this. So you have a system whereby anyone can permissionlessly add a piece of data to this big, open, shared, composable data lake. Well, when you do so, that means that the information can transfer from one application to another seamlessly. But if it were to transfer without the licensing information, without the token, like, the information about who owns it, who started it, all of that stuff, it just wouldn't work, right? And so we built this system. It's not like a traditional smart contracting ecosystem. It's building just for content-based finance, basically. Yes, where the data, the contract, the tags, the metadata, it's all in one thing. It's one identifier. You can't transfer the data without also transferring the contract information, without also transferring the tags. And that means that when you query the network and it says, oh, sure, Alice sent a post 2 days ago on a social media network on top of Arweave, and she sent it to, it was an open message, but it added Bob, for example. So you can query for those types of things, and that just returns an identifier. And then in your application, when you want to render that to the user, you can say, oh, who's the owner of that piece of data? Like, what's the NFT that Alice minted when she sent that message? Who's the current owner? All of that is atomically moving between the applications seamlessly and trivially from the data, from the developer's point of view. And so we see that we want to move away from this world, which is Web 2 essentially, where you have data, code, and infrastructure tightly bound behind basically domain names. Like twitter.com is not just the code, right? It's the data. It's also the infrastructure on which the twitter.com code runs. It's all bundled into one. And we see a world where the web becomes this big open library of well-licensed content, which is leading to developers creating revenue streams. And those revenue streams can even be tradable, right? And it's all moving around in a seamless fashion between the applications. And the infrastructure can be swapped out of the user's request. So you can access all of this content on arweave.net, or you could use gateway.io. It doesn't matter. And so this world, we're pretty excited about it. We think that it's happening now. All the pieces are falling into place to make it work, and it's growing. But it's still extremely early, so it's really quite exciting. We also think that where this goes is potentially, and this is more, I would say, exploratory. But when you have a system like this, and at the same time, the ability to create user interfaces with AI became trivial, right? So we went from this model where there was a tight coupling of the user interface with the data and the infrastructure, right, to a model where the user interfaces can live on an open shared ledger and be pulled back on different infrastructure. So they've become much less important, and they're not associated with the data, which means anyone can just make a new interface quite quickly. So the interfaces become smaller and smaller. It's kind of like there's this blog post from Union Square Ventures called the Fat Protocol Thesis, where they basically describe that in the early web, pretty much up to 2000 or so, people were really excited about building protocols, and they were open and composable and permissionless, but they didn't generate any money. And then they were building companies on top. And that's, so much so the case that the protocols were thin, if you will. They didn't accrue value, that Tim Berners-Lee actually issued an NFT, of all things, of the HTTP 1.0 source code, his first HTTP server and client. He issued that on Arweave during the NFT bull run for $1.5 million. But that was his way of monetizing the protocol that is the web, which is crazy, of course, because the web has generated, I guess, tens of trillions of dollars of value. So the protocol in the old version of the web was very, very thin. It didn't collect any value. Well, USV's argument in the Fat Protocol Thesis is that the protocols will now become value accruing, and then the applications on top will also accrue some value, but suddenly these protocols are investable, and the venture capitalists, so they get excited about that. Well, I would argue that what we're looking at here is a web where the data is sort of fatter and the apps become thinner and easier to build, faster to build, and to some extent replace. And then as a developer, what you're doing is you're building these applications and you're getting cut onto the cap table of all of the different pieces of data that are being uploaded through it. So you want to build the best YouTube-like UI or the best TikTok-like UI because you want people to upload through your application. And when they do so, you're going to receive some of the PSTs, these profit-sharing tokens that are embedded inside the application, which entitle you, because of the universal data license, to some of the revenue stream from that piece of data. And so you're pretty happy because you just want to build great apps that get you essentially ownership in data. And the users are happy because the data is flowing between the applications. So they own their own voice with their keys, right? They can't be deplatformed. And they're publishing to all of the applications at once, not just one. And they're setting the terms. The developers are happy because there's this kind of crazy situation where you get to build on top of all of the data across the whole web, rather than when you start a new application, there's no data inside. And that means like making TikTok is, okay, yeah, I see YouTube, that's kind of cool. But I think there's a niche which people will like, which is all of the data inside YouTube, but just the clips that are 30 seconds or less in length and vertically oriented. And now building TikTok goes from this like half-decade process to you can do it in a weekend. So this is, we think, anyway, really exciting. Well, because AI came along at approximately the same time as technology did, you can now use AI to generate the user interfaces for you. And what if you could use AI to generate the user interfaces on demand? We think that is very, very interesting, because it means you could generate on-the-fly apps, sort of ephemeral applications that are purpose-built for one specific user. Imagine that Alice really cares about truthfulness markets associated with data that are social media posts. But Bob doesn't really care about that. He just wants to see which of his friends are liking the posts. Well, a piece of AI could actually just generate them apps that are perfectly suited for them, building on the same shared data set, on demand, on the fly, perfectly customized. And we're actually building this at Forward Research. So yeah, it's pretty exciting. Anyway, thank you so much for giving me the opportunity to speak to you today. I hope some of that was interesting. If you're interested in learning more about Arweave, just Google Arweave. There's a ton of stuff online about it, or Baidu or what have you. And yes, if you'd like to come and work with us at Forward Research while we build out some of the core elements of this, please just reach out to us on Twitter. Our DMs are always open. And mine too, my personal Twitter account is Sam E.C. Williams. Yeah, I'd love to speak to you. Thank you so much.
Thank you so much, Sam. It's really awesome to see, Airwave has been building a lot of infrastructures for public good to flourish. Yeah, talking about Tim Berners-Lee, I happened to met him last week for Deep Camp, which was amazing. I didn't know he studied source code as an NFT, which is a quite a novel and cool idea. It's a very like a Tim Berners-Lee-ish. I think we have like 1,400 people are watching this online. I'm really wish we have time for questions, but unfortunately we're running out of time. But I really express the gratitude again to you for coming back to Shanghai. It means so much for the community. It means so much for us. Thank you so much.
It was great to speak to you. And if you have any questions, just shoot them to me on Twitter. Amazing. Thank you.
Absolutely. Thank you so much, Sam. Bye.